Thank you for the opportunity to speak to you about this. It's something that I have spent lots of time on all through my PhD and until now, and it's always good to show this data again with some slightly new spins. But I have been giving this talk, unfortunately, in a way for a few years now because things haven't changed as much as I would like. So I will be talking to you about a critical perspective on the implicit relational assessment procedure, a task that came out of and has served to shape English save, sorry, pop up, and has served to shape relational frame theory as it stands today. So a little piece of background on myself. I did my PhD, finished back in 2015, surprisingly long ago already. I did it with Dermot Barnes-Holmes back when we were all at Maynooth, and I was heavily involved in the development of the IRAP and relational frame theory. I've published on and written about pretty much every element of the IRAP that you can think of. It's substantive usage. It's links to relational frame theory, best case usage guides of like how you should use it, more robust scoring algorithms, procedural variants, other implementations of it that are open source, curated large data sets. That is to say, I know the IRAP. I know the IRAP very well. I spent my whole PhD on it and years thinking about it since. I since now work arguably no longer within the ACBS community, although I still have a great affinity for ACBS, but I now work as a meta scientist. So where my objective study is no longer humans in general, but the behavior of scientists studying the production of scientific knowledge itself. So I've got lots of experience with thinking about issues of replication, measurement, post-publication critique, and these two things come together when I think about the IRAP. And together, I have to plug my current wares to start with by saying that I now co-run the Error project, which we announced only last week. It's one of the first effort globally to estimate the prevalence of errors in published psychology research and indeed other research. So check it out, error.reviews. It's a cool project. So to preview my conclusion, to come out the gate a little hot on this, as someone who has experience in the IRAP and as someone who has experience in meta-science, measurement, error detection, and replicability issues, my conclusion is that the IRAP is not fit for most purposes and that the literature is heavily corrupted by false positives and confounded results, and that the research community involved in doing this work is generally disinterested in addressing and correcting these errors. That's, not, it's strong stuff coming at the gate, but that's where I have to end up. And that's where the data takes me. And let me show you that data. Of course, I could not have to show you any of this data if you can accept this core premise that I should have accepted way back at the start. The false premise of the IRAP is, unfortunately, to everyone's chagrin, that 18 pairs of reaction times cannot measure anything reliably or validly. That's the number of reaction times that we use to calculate a single IRAP trial type D-score. Go and talk to any of your colleagues who work with reaction time data a lot. Go talk to psychometricians or diagnosticians or measurement folk. Say, I have 36 reaction times in 2 blocks. I want to create an individual differences measure of something meaningful and reliable. Ask them, how feasible is that? You don't need to give them the rest of the context. There is no magic way to get that amount of information out of this little data. Reaction times are just too noisy, especially in this task, which is a fairly noisy task. So that's unfortunately the premise that the IRAP literature is built on, and that years has flowed from since. But of course, it's not enough for me to leave it at that slide and call it a day. Let's walk through the issues that have come from this by not accepting this premise. Let's take a step back first, and I apologize, I am going to have to speak quite quickly because there's a lot of content here because I've worked on this for years. What is the IRAP? I will spend all of this talk talking about and trying to answer the question for myself and for everyone else, what is the IRAP? Procedurally, surely, simply, we can say that procedurally, the IRAP is a behavioral task with 4 independent trial types. What do I mean by that? That on each screen, you get words like sample stimuli, like I am, and target stimuli, like likable at the top in the middle of the screen. And then you have to respond on different blocks. Sometimes you have to respond with true, you have to, and then other times you have to respond with false. They are the required answers. And your reaction time biases are then used to make inferences about whether that's strength of relational responding or implicit attitudes, depending on who you ask and when. If I am faster to affirm this than to deny it, I'm said to have a self-positive bias, basically. And what makes the IRAP sort of arguably unique among different types of measures like this that we might, but not everyone, will call implicit measures, is that the IRAP quote from a paper with me and Martin Finn and Dermot, the IRAP is seen as providing a measure of the strength of the probability of 4 functionally independent relational responses. What do I mean by that? Whereas other tasks create one overall score that's like you have a self-esteem bias of some sort, nominally, the IRAP can do this for the 4 different relational responses, like self-good, self-bad, others good, others bad. This is at the core of the salesmanship of the IRAP, that it needs to be able to do this. And this premise is repeated constantly in the literature. It's said explicitly at times, like this quote. Other times you will contact it implicitly. Sometimes, often, you will even contact it in peer review when someone who is a big pro-IRAP person will say, you must analyze the data like this, when actually, yeah, there may be reasons to do so otherwise. So the IRAP is a measure with 4 trial types, except it's not. We know it isn't. And the strange thing is that even authors who are co-authors of papers that have shown that it's not often press for the fact that it is. We have both experimental and correlational evidence that the trial types are not reliably independent of one another, and that the contents of one influences another. I showed this back during my PhD in a paper with Dermot and one of our students at the time. Experimental evidence that if you manipulate the content of one trial type, you can influence the contents of another. So they're not functionally independent, regardless of what your interpretation of functional means in this context. They are experimentally proven to depend on one another. And then I used a big data set, about 2,000 IRAPs across different domains, showing this correlationally too, that if you just correlate the performance on different trial types, they're pretty well correlated. So I don't know how they can be functionally independent, and we seem to keep forgetting that they aren't, but it keeps being repeated that they are for whatever reason. So what is the IRAP? A behavioral measure, a behavioral task with 4 independent trial types? Not so much. The evidence doesn't actually show that. It tends to show the opposite, and I actually don't know of any evidence that shows that it is. There's lots of evidence that assumes it is by treating it differently and then getting different outcomes, but that's begging the question, right? It's using your premise as your conclusion. Okay, so what is the IRAP? Let's try again. It's a measure of the strength of pre-experimental verbal relations. This is one of the oldest kind of style of RFT-ish definitions, like the early attempt at saying, like, what does the IRAP try to measure? Something to do with verbal relations that happened before the task. The idea here is that, again, if it is a race IRAP, that on the top of the screen, you'll see things like either white people or black people, and in the middle of the screen, you'll see positive and negative. And indeed, people show these biases. You'll show you're faster to affirm that white people are kind than to deny this. But the strange thing is that you also show unexpected relations that you shouldn't. And so we published these because they were very unexpected at the time. Me and Dermot did this during my PhD, found that people say that dying is positive, and this was weird to us. So we published it because we thought people should know. But we kept pursuing this, or I did at least. It's not merely death positive, it's also things like Hitler is positive, right? I found this strange. Chad Drake found this extremely strange. I ran this original study in around 2012, within a year or two of then. We showed it to Chad. Subsequently, he replicated it. He was sitting on that data too for years, puzzling about it. He finally put a preprint out last year on it so that that data is out in the open. So this seems to be a replicable effect found in 2 different populations on 2 different continents by 2 different independent researchers. Hitler's good on the IRAP. The thing that's really strange, the thing that provides a genuine test of this claim, that it is something to do with the pre-experimental relations between these stimuli, is that you can put in things that have no pre-experimental relations, no strong ones. You can put in non-words. You can put in cugs and vex and joms and glicks, things that don't mean anything, and people will still show a cug positive effect. Again, this isn't speculation. I showed this back in, I think, around, again, 2012. I showed it to Brian O'Shea. He directly replicated it and published it, which robbed me of the motivation to publish mine. But yeah, I'm glad the data is out there. But know that this has been independently replicated. Again, you show cug positive and vec positive effects when you shouldn't. This is problematic because it's a direct test of the claim, the core premise of what the IRAP measures. Let me come at this a different way because it's very important. I did this through a different, more correlational way of doing this. I collected data from lots of different labs, from mine and Chad Drake's published and unpublished work, all using evaluative IRAP, so that the target stimuli in the middle are generally the same, they're positive or negative, and it uses true or false. But the thing at the top of the screen changes the domain of these attitudes or stimuli, from body image, death, friends, enemies, Lincoln, Hitler, race, religion, things like this. And then all I do is plot them. Just plot them all together, and what you can see is that the means generally don't follow a similar pattern. They do follow a similar pattern. This wedge shape is the first thing. The time that I heard this referred to, is Sean Hughes referred to it around 2011 in his own data, and said, do you often find a kind of a wedge shape, like a Big Dipper shape in your IRAP data? And I said, yeah, I kind of do. And we do. The issue was we weren't looking for it specifically until now, or until I put this out in around 2020. It's hidden in everyone's data. We just needed to collect more of it. So the hypothesis here, remember, is the IRAP is a measure of the pre-experimental relations between the sample, example, Hitler, and the positive, the target, which is positive. But it's not if you keep getting the same pattern regardless of the stimuli that you use in it. And if you look at this from in terms of variance accounted for, almost all of the variation in IRAP effects is this generic pattern between the trial types. And very little of it is related to the stimulus domain being assessed, or any interaction between the stimulus domain and the trial type. So what's the real test here, though? The real test is when you compare it to non-words that have no pre-experimental relations. This is all of the previous domains collapsed into one in blue, compared to non-words, cogs and vex, labeled unknown in green here. If there are no pre-experimental relations, the IRAP is not measuring pre-experimental verbal relations. What is it measuring? Maybe more likely, not the relation between the sample and the target and the top and the middle, but instead the middle and the bottom. It's just the fact that the positive is more positively valenced. The true is more positively valenced than false. So when anything positive on the screen, participants are more likely and quicker to hit true. That's it. Pre-experimental verbal relations, yes, but not between the thing that anyone cares about. Not between the sample and the target stimulus that defines the domain you're looking in, just this other kind of method effect that we care about a lot less. So mean scores on the IRAP trial types are extremely strongly confounded. We have known this for more than a decade. People independently agree on this. They have replicated this effect. I want to emphasize, this is not controversial. I collected data on it in 2012 and finally put it out a long time later. Brian O'Shea found it in 2016 in a direct replication. Martin Finn and Dermot Barnes-Holmes have done multiple studies on this, and people are calling it different things: the generic pattern, the positivity bias, the single trial type dominance effect, but all of it relates to the same underlying point, which is you get effects on IRAP trial types that you should not. Okay, so I'm trying to convey to you that the presence and the replicability and the generality of this effect is not actually controversial. Lots of players in the IRAP community admit that this is the case. The problem, in my opinion, is that people are not acknowledging its necessary implications. It represents a confound that invalidates the claims of several common statistical analyses of IRAP data. Anything that involves the means, the means, and especially comparing the means against each other and against zero and between trial types. I unpack this on this plot and which analyses are likely to be valid versus invalid due to this confound in the 2020 paper. This is a problem. I want to be very clear. This is a big problem. Confounds confound inferences. They confound claims that you make in papers. It is scary enough that Chad Drake and I decided to systematically review the presence of erroneous claims in the IRAP literature. So what we did was we found every IRAP paper we could. It was about 100 back in 2019. And then we read them all and we classified whether their conclusions, their inferences or claims were based on this type of analysis that was confounded and undermined, if not entirely invalidated. What did we find? 84% of the published IRAP papers up until 2019 contain at least some confounded conclusions. This is bad. This is slightly more objective because you can say those analyses were run and reported and interpreted. So at least some of them are confounded. This one is a little more subjective. I completely admit that it is very difficult to isolate what a researcher's core claim is. People are often not sufficiently clear about this. We have decent inter-rater reliability because two of us scored them. We reckon that 78% of these are core conclusions. So when you pick up an IRA paper, at least the ones published before 2019, a lot of those conclusions and even many of the core conclusions are substantially undermined by a confound that many people agree exists, but are not interpreting or like sufficiently applying the necessary implications of this. So my issue here is not even the fact that it exists, it is the lack of reaction to it. The ratio between the scale of this problem and the inaction that I see around it is worryingly large. And I want to emphasize that unfortunately, we can't attribute this to lack of awareness, because back in 2006, Blanton and Chicard made this exact point about the implicit association tests on a great paper on arbitrary metrics, and the IAT literature adapted. It has mostly stopped doing those confounded analyses since then. And we were aware of this, right? I can tell you from being in the IRAP lab from 2008 or 2009, I started doing IRAP research as an undergraduate student, that we talked about Blanton and Chicard all the time and whether it was a problem. And then in 2011 to 2013, when these wedge shapes started coming out a lot, Sean Hughes, Dermot, and I discussed the problem a lot. And later, when we were all based in Belgium, Dermot's lab, all of Jan de Hara's lab, we had multiple joint lab meetings on this specific issue because some of us, me included, felt that it posed such a threat to our research findings. But not much has changed since. So yeah, the inaction I find to be problematic, and we can't just put it down to the fact that, well, we didn't know. This is what I mean by systemic inaction based on problems. So what is the IRAP? Attempt number 2. It's a measure of the strength of pre-experimental verbal relations. No, not the ones we care about. Maybe some other ones to do with the targets and the response options, but not the ones we really care about. Okay. What is the IRAP? Please answer the question. And I hear you saying, well, it's a measure of something. Who cares what that thing is, but it's a measure of something, right? Let's lower the bar here. Multiple other authors have conducted reliability, generalizability meta-analyses, including Nima's meta-analysis in 2013 and Calvin Lai's one as part of a much bigger project on implicit cognition generally. Nima's paper is great, but it's based in 2013. It's over a decade old. It had a very small sample size. There were very much fewer IRAP papers then. So its estimates are, based on fewer participants, and I would say probably suffer from publication bias to no fault of Nima. Calvin Lai's paper provides similar-ish estimates using larger sample sizes, but I have issues with those papers. They extract effect sizes from articles that don't report those effect sizes or where the design does not allow you to extract test-retest reliability from it. And I can't explain where those come from. We don't have time to do a deep dive on that, but I have issues with the Line-Greenwald meta-analysis, at least insofar as it pertains to the IRAP data. So a slightly old small meta-analysis, one which I have problems with, so I did my own. I asked around, I put all of my published and unpublished data together. I put all of Chad Drake's massive IRAP data sets together. And we asked around on the listserv, we approached people, we said, anyone who has data that meets our inclusion criteria, please give it to us and we will put it in this meta-analysis. And it has a lot. And it has many advantages over other ones. It has fancy statistics. It's an individual participant, multi-level moderator meta-analysis. It uses more advanced stats that are more contemporaneous, like it uses ICC2 as a metric of test-retest instead of just Pearson's R, things like this. And it does trial type level analyses. Since many folk use them, I'm not endorsing trial type analysis, or am I particularly against them? The evidence is just, yeah, mixed to bad. But because many people use trial type level analyses, it's important that we quantify reliability at the trial type level. Previous meta-analyses haven't done this. It includes both published and unpublished data following Cochrane's best guidelines on how to quantify effects and much larger sample sizes. So what do we find? Much larger sample sizes, about 1,700 IRAPs, and some of them test-retest as well. And we find that the IRAP ranges between mediocre internal consistency, if you consider the overall D-score, to abysmal, if you look at the trial type level. And at test-retest level, it ranges between abysmal and abysmal, like really abysmal. Remember, reliability is a signal-to-noise ratio of the variance observed in an effect. What percentage of it represents meaningful signal? And this says that in test-retest, arguably the more important metric, because it's basic stability, as in, like, if I measure something with a ruler and then I measure it again, I should get the same result-ish, this 2 times. Test-retest reliability, foundational concept, also speaks to individual level utility in a way a lot of people don't appreciate enough. And it's on the floor bad. It says it's mostly noise. So what does the IRAP measure? It's a measure of what is the IRAP? It's a measure of something? Not really. At an individual differences level, it's mostly noise. It's utterly unacceptable to have a reliability that low. The replicability of findings that low is terrible. It bodes terribly. When I've asked people about this in the past, one of the main responses, and one which was a genuine concern and which it needed addressing, was surely it is a measure of something, because Vahey et al.'s 2015 meta-analysis shows that the IRAP has high criterion validity. So it can't be a measure of nothing reliability-wise and a measure of something very good criterion validity-wise. One of these has to be wrong. I totally agree. And I had to do my due diligence here because it cannot be both. So I looked into it. Nigel Vahey, Emma Nicholson, and Dermot's paper published in 2015, while we were all at grad school together, claims that the IRAP has high criterion validity, a correlation and mean correlation of 0.45 with clinical criterion tasks, which they say is roughly twice what the IAT is. Big if true, right? Great measure if true. Almost unheard of good measure if true. This paper is frequently cited for its power analyses as justification for the fact that IRAP studies have very small sample sizes. People say, well, but it's okay because Vahey says this is okay. This is actually a misuse of the type of power analyses that it conducts and reports. You can't use that power analysis to justify this because unless you're doing it, that's not the way the power analysis works, but we don't have time to get into that right now. You shouldn't cite it for that reason. Something is amiss, even intuitively, but also specifically mathematically. Criterion validity cannot be this high if reliability is this low. One of them must be wrong. And it is not for me to critique my own work. I have done the best I can to do so. So please, somebody else take my reliability meta-analysis and critique my code, my data, tell me I've done something wrong somewhere. But what I can do is I can critique Vahey's to say, I think you may have some issues here. So to start with, Vahey et al. Described themselves as using a Hunter and Schmidt meta-analysis, and Hunter and Schmidt described their own method as involving correcting observed effect sizes for their reliability or unreliability. And the tutorial article that Vahey et al. Reference in their paper provides code to do this. But Vahey et al. Doesn't seem to do this. So they don't really do a Hunter and Schmidt style meta-analysis. I'm not playing gotcha here. This is a very minor point. The reason why I bring it up is that Hunter and Schmidt meta-analysis cares deeply about reliability. And so I think we should too here. We should follow through with this. We can do it ourselves post hoc. We can take Vahey's estimate of criterion validity, which is an observed correlation between X and Y, X being the IRAP and Y being these other criterion measures, and they find an average one of 0.45. Now, using the formula for correction for attenuation, which is listed below, and some assumptions, all of which are very, very generous. They assume that the average correlation, so the average internal consistency or reliability of the criterion task is 0.9. And let me note that if you lower that number at all, the situation gets worse, not better. So this is a very generous interpretation. If you correct for my estimate, my Chad's estimate of internal consistency, you see that the IRAP's true corrected criterion validity is 0.91, a correlation of 0.91 on average. Not with any specific measure, generally with criterion measures. The IRAP correlates with everything almost perfectly. And if you correct it for test-retest reliability, it correlates more than perfectly. Hopefully, some of you have spotted that it is not possible to have a correlation of 1.12. And if you observe attenuation corrected correlations that are above the boundary of 1.0, it tells you something's too good to be true here. So let me sum this up. Either the IRAP has near perfect true criterion validity and correlates on average, as in 50% of the time it's even better than this, with clinical criterion variables nearly perfectly, better than any known psychological measure ever. This isn't me being superlative. These are what the numbers are saying. It is either the best measure ever, in which case we should use it in every study, genuinely. If it is this good, get everyone else to drop their measures and use the IRAP. I would love this to be the case. We would have cracked most of psychology. Or something isn't right with Vahey analysis. So I dug a little bit further. Well, first of all, the forest plot that you get in most meta-analyses reports weighted mean effect sizes, and Vahey have done quite well in giving us their supplementary data, their individual effect sizes and sample sizes. So the basic check here is recalculate weighted means. This is things just like 5 values of effect sizes and 5 values of n, and it's one line of code to recalculate their means. And they don't in 2 of these 15 cases. These means are not recalculated. This simple step, something is not right. There is some error somewhere. Doesn't invalidate the whole thing, but it's a sign that something is amiss. And these are not obscure papers that the authors would be unfamiliar with. One is by Nicholson and the other one is by Vahey. But they have not recalculated their own effect sizes correctly. Look, to err is to be human. I'm not coming at these people individually. But I'm saying there's a problem in this paper that needs to be corrected and acknowledged. So I kept digging because we need to know which one is wrong. Well, the forest plot, sorry, their report, I think I made a typo there. The results reported in their forest plot also don't match those in the funnel plot. It's the same effect, weighted mean effect sizes. So I just extracted them and compared them. And you see that one of them, a different one again, is wrong. The black dot is what exists, and it should be the red dot, or vice versa. It's hard to know which one is wrong. So it's important to do these types of scrutiny to know, are these analyses robust? So it seems like the plots are off and it seems like the data is off. Well, if I take their data or those other versions of it, can I reproduce their results? I took the scripts in the tutorial papers that Vahey told me that he used, and I found that they either produce different numerical results than those reported in the paper, or worse, this code cannot produce those types of results at all. So at minimum, the authors did not conduct the analyses that are reported in the article and that Vahey told me via email that he said he did. They also don't seem to do any plausible variation of this analysis that I can think of, including like obvious errors, like what if I swap this and this, or I mistakenly use that. I cannot get this to spit out the numbers that are reported in the paper. I kept digging. Vahey et al. Report their inclusion criteria as fairly simple. They say it's covariation between an IRAP effect and a corresponding clinically focused criterion variable. Nice, concise, good definition. The problem is that when you look at their effect sizes and the description of where they came from, and then you check that those descriptions are right, 40% of these effect sizes involve no criterion variable. They're just mean scores on the IRAP, as in like these participants showed a mean IRAP effect that was different from 0. These cannot provide evidence of criterion validity. They don't meet the inclusion criterion, and not at some like geeky technical level. Like they cannot speak to this, 40% of the effects. And as an aside, it's not hyper relevant here, but we also know that these effects are confounded anyway. So then arguably you would find them whether or not these suicide or death IRAPs or whatever were just COG-VEC IRAPs. And it cannot speak to criterion validity. Furthermore, the authors seemed to, when I went back and checked, they seemed to omit many smaller effect sizes that nonetheless met their criteria. So for example, they say they extracted an effect from Timko et al. 2011. So I went back and read it. And in the same paragraph, Timko et al. Report a very similar effect size that still meets criterion, inclusion criteria, but is much smaller and was not included. That's not good. And again, to err is to human. And if this was one or two effect sizes, this would be understandable. Like we know this is a common effect. This is not anything specific to this meta-analysis, that effect sizes are hard to reproduce in meta-analyses and get missed or mistakes are made sometimes. It's the scale of the issue. They emit lots of smaller effect sizes. Vahey et al. Included 56 effect sizes. I read the same papers and applied the same inclusion criteria, and I found 171. So what did I do? I refit analyses using the same inclusion criteria from the same papers to to estimate what the meta-analysis arguably should be in a reproducible, better checked manner. And it's not R of 0.45, it's more like R of 0.22, which puts it on par with the IIT. And more importantly, the really important thing here is that the power analysis now says that instead of needing 37 participants per IRAP study, which most but not all, crazily, IRAP papers meet, it's now 273. And what proportion of the IRAP literature has at least 273 participants? 0. So this isn't my logic. This is Vahey et al.'s logic, that this is what we should be powering it to. I think it's 273. I've revised this downwards over time. I've given previous versions of this where it was much higher again. I tried to be fairer and fairer and fairer, find any possible error in my analysis. Please inspect my code, inspect my data, see if I am wrong here. But it seems to be scarily high, not by my logic, but by Dermot, Nigel Vahey, and Emma Nicholson's logic, that every IRAP paper is underpowered. There's many other issues with Vahey that I just don't have time to get into, but see the supplementary materials. Again, like the last time, my issue here is not that errors exist. To err is too human. My issue is the lack of receptivity to doing anything about these. There is no way to get around mentioning names and talking about people, because it is the behavior of individuals that is important in this case, right? I asked Nigel to help me do this validation before I started it. I asked him to share his code with me, and he told me that he had the code, but he wasn't willing to share it until I had substantive errors that I wanted to report to him. And of course, that's a little bit backwards. Help me check that there are errors, and then I'll get back to you. Then I had to do it myself. I had to reconstruct it from these code and various things. It was very laborsome. But I shared all my data and code with Vahey prior to my 2019 ACBS presentation. That was 5 years ago. He also attended that presentation. So I know that he knows of these issues because I've talked to him in a room full of people about it. I've also tried to publicize my work, whether published or unpublished, online wherever I can. I give talks like this. I talk about this issue. And I've had no communication from any of the authors since. No correction has been issued. And unfortunately, it keeps getting cited. And it keeps getting cited by authors of Vahey et al. Dermot cited it 4 times in 2022. So this isn't good enough to me. There are substantial, demonstrable issues in this paper. And if they're not, if I'm wrong somewhere, please show me where. Yeah. So what is the IRAP? The key question. A measure of something? No. Mostly noise? Mostly noise. What about Vahey et al. That shows it has good criterion validity? No. Criterion validity from 2015, the 2015 meta-analysis is deeply, deeply flawed. It's mostly noise. What is the IRAP? This is my genuine, heartfelt answer. I'm not giving this lightly. I've thought about this at great length for years. I have put untold hours into collecting this data and seeking out critique wherever I can for it. This is my genuine answer for you of what I think the IRAP is. In my opinion, the IRAP is a device that converts statistical noise into spurious, statistically significant p-values so that they can be published. This sounds harsh, but it is absolutely supported by the evidence. A paper I published in JCBS last year showed that sample sizes, step back for a second, the IRAP literature is a breeding ground for false positives in the following ways. One, it uses tiny sample sizes that are smaller than were used in social psychology before the replication crisis, which hit them first. The IRAP literature is still not up at pre-replication crisis levels of social psychology in 2011. It's still trying to get up to that level. It has a median statistical power to detect the average published IRAP effect, which is R of 0.22, bearing in mind the criterion validity is now estimated to be 0.22. So they're very similar, 0.20, 0.22. So whether you're using the IRAP as everyone else uses statistics, or as some IRAP researchers argue that they're using it for inductive purposes to discover hypotheses, not test them, you can't discover effects that you can't detect, right? It's a contradiction in terms. Discovery research needs high power, so does testing research. The sample sizes are woefully small. Similarly, or paired with that, we use on average a very large number of analyses with very many experimental degrees of freedom in IRAP studies. Put together, these and other factors are all the necessary conditions for false positives. See all of the replication crisis. This is what Simmons pointed out in 2011 that changed the course of lots of psychology, areas of psychology research, that tiny sample sizes, large numbers of analyses, and experimental degrees of freedom breed false positives. The IRAP literature has yet to learn this lesson, even though some of us have been talking about it at least 2015. Well, that's nearly a decade ago. Let me demonstrate this to you. The typical IRAP study, and I know it's typical because I systematically reviewed every one of them, 151 of them. So this is what the modal IRAP study looks like. It has, as I said, about 40 participants. It's higher in recent years, but about 40 participants, and it divides them into a very large number of cells within the trial by between groups, repeated measures ANOVA, sometimes with an extra 2 by for the block order, which gives you somewhere between 3 and 7 p-values. Then it does follow-up t-test comparisons, that's another 4 p-values, and it also does one sample t-tests on all of the trial types, again, 4 to 8 p-values. And they tend to also calculate correlations between the IRAP and other variables. This is 4 or more other p-values, one for each trial type, assuming there's one external measure. Let's put the correlations aside and just think about the ANOVAs. That's around 20 p-values. It's 18 to 24, I think, p-values per study. 20 p-values is a very interesting number because with an alpha of 0.05, if all hypotheses are null, 20 randomly run significance tests will generate around one false result. So this alone, this tendency to fit so many p-values to the same data produces false positives by itself. You don't even need experimental degrees of freedom, or what you can call p-hacking, although that pulls in like intentionality for some people. So experimental degrees of freedom, whether people intend to or not. It's only higher again if you do. But don't take my word for it using this back of the envelope calculation. Let's talk about this in a far more technical way using a simulation study. If you don't know what a simulation study is, don't be surprised. Most of ACBS community does not use simulation studies, but they're very useful and we probably all should, right? You can see Halgren 2013 for a great introduction to them. And in 3 oversimplified lines, what they involve is using the same assumptions as the analyses rely on to generate pseudo-random data, in this case, normally distributed data from a population where all effects are true nulls. So you know for a fact that all of these effects are true null zero effects, except if I say otherwise. And then you apply the same analyses to them. So you apply this repeated measure ANOVA plus all the follow-up t-tests, and then you assess significant results were found. And then you do the above a very large number of times, and you calculate the long-run false positive rate. Now, we're all used to thinking of one false positive rate as the same as if it's alpha of 5, you should get 5% long run false positives, but not when you have a ton of family-wise error like this. It's much, much higher, as this simulation shows. So first, putting aside the false positives, if you believe in the generic, you will get some significant results 100% of the time. This is technically a true positive, not a false positive, because the effect does exist. It's just misinterpreted because it's a confounded one. So you will detect these effects, assuming you believe the generic pattern exists. And remember, everyone basically does. You will be in a minority if you don't believe this effect exists, whatever you choose to call it. So if so, you will detect this effect in most cases, and most people will make conclusions on the basis of it, as we saw, like 80, 78% of people making erroneous conclusions about the domain instead of, yeah, we found the usual the usual pattern that people always do. So that aside, that true positive but result aside, let's put aside that particular one and treat everything as if it's null. What do we find? Well, it depends how many analyses we run, but the third line down here, the one labeled 3, which is the 4x2 repeated measures ANOVA with hidden multiplicity, plus the between groups t-tests, plus the one sample t-test, all of this rolled into one, means that the typical analysis run on IRAP data, if it was perfectly pre-registered and no one deviated from what they said they would do in any way, it's still a false positive rate, not of 5%, but of 37%. And the moment you add even a sprinkle of experimenter degrees of p-hacking to this, of analytic flexibility, or what we call p-hacking, agnostic to people's intention, this balloons to 75% or higher. And as you can see, the number of participants you use don't matter. It wouldn't matter if we solved the power and ran studies with 500 participants. Because as long as these problems of hidden multiplicity, multiple testing that's not and analytic flexibility are, as long as they're not corrected, the false positive rate is gigantic. These are only 2 forms of analytic flexibility that you can demonstrably show from the published literature they are there. Covariate flexibility means optionally include the block order sometimes and other times not. You'll see the same authors across time, adding it, deleting it across papers. So it's not a just choice. It's analytic flexibility. I know this from experience. It's the way that we were trained to do it, of like, well, see if it works out block order. But like, that's hard for me to evidence, right? But I can show you, I can tell you, you can see it happen in the literature across papers by the same authors. Data processing flexibility means like invert or collapse the trial type. So you can score the R by a few different, and if you do more than one of them, this is what happens. And when you do both of them, which most papers do demonstrably, you get this false positive rate that is, astronomically higher than the nominal alpha rate of 0.5. It's 75% or more, no matter how many you run. I want to emphasize here, this is terrible. It means that this alone, aside from the generic pattern, which guarantees some significant result you can publish in every paper and is confounded, it means that even if that wasn't the case, and there will be these other results in the papers, every like 2 to 3 IRAP studies you run will generate some novel, complete false positive that gets introduced into the literature and discussed as if it's real. I want to be very clear that as bad as it also cannot be written off as sort of, well, there's problems everywhere. No, the IRAP is uniquely susceptible to this because it has so many degrees of freedom in its scoring, and so many p-values are calculated on the same data in such small samples. It is a perfect storm of poor research practices, unfortunately. It is, as Chad Drake called it, a noisy measure that measures noise. There is no other way to put this. So what is the IRAP? That is unfortunate conclusion, having studied and worked with it for, what, 15 or 16 years now. It is a device that converts statistics into spurious, significant p-values that then get published. So what should we do about this? I'm very near the end now. What should we do about this? Many people, when they hear from me, ask that I say something positive at least, because this is heavy stuff, right? Can't you say something positive, or how can we fix this? And I used to give more sort of, well, we could do this, we could do this. And now what I say is, look, to pull an act move on us all, 150 publications, more than that now. After 20 plus years of research, after literally millions of dollars of funding poured into the IRAP, what should we do about this? Something else. Anything else. Just do something else. To use the act metaphor, I think it is that we drop the rope on the IRAP. No amount of pulling solve this. It is only fighting this battle that we are choosing to have, and we can simply stop. I'm going to continue publishing IRAP work insofar as I get these papers out, have my critiques heard. I will respond to anyone who wants to have this debate. But I mean, I haven't collected new IRAP data in several years now, and I would not do so. Back to the false premise. This was all foreseeable if we had thought about this using our introductory methods and measures textbooks. 18 pairs of reactions cannot measure anything reliably or validly. If you don't want to deep dive on my research here, and you want a quick and dirty outside opinion of this, this is what you should take to any of your measurement colleagues or psychometrics colleagues or reaction time modeling colleagues. Ask them, what can I measure reliably and validly as an individual difference measure with 18 pairs of reaction times? And they will tell you nothing. It cannot be done. Figure out how exactly to close this, and eventually I came back to Chad's blog, which he wrote. I left his tenured academic position to take a clinical position with the VA. So I'll finish on this, which is impactful, and I think all too true for me too. He says, and you should read the full blog, I wasted most of my research career on a measure that has been and continues to be misused and actually seems to be just about useless. The warning signs of the IRAP that has been oversold to our community have been present in the data for years, but have been ignored, often willfully. So I'm going to click through my slides with my reference so that you all have a copy of them. If you're just watching a video, you can pause and pull these references out. Please, again, inspect my data, inspect my code, see if you can find a problem anywhere. Let me know. It's all open source. And thank you for your attention.